The binomial distribution. Factorials. The product of the first k positive integers, counting numbers, is called k factorial and is denoted k exclamation point. In symbols, k factorial equals k, k minus 1, and so on until you get to 2 times 1. This means if I have 4 factorial, that is equal to 4 times 3 times 2 times 1. We also define 0 factorial to equal 1. Binomial coefficients. If n is a positive integer and x is a non-negative integer less than or equal to n, then the binomial coefficient n over x in parentheses is defined as n over x, which equals ncx, which equals n factorial divided by x factorial times n minus x factorial. The notation n over x in parentheses is just another way to write the combination of n choose x. Example, simplify. 8, 3. So we're looking for the combination of 8 choose 3. And when we calculate that, we type 8, go to the math menu, over to probability. The third one down is combination. Then type 3, enter, we get 56. The combination of 8 choose 3 is 56. Bernoulli trials. Repeated trials of an experiment are called Bernoulli trials if the following 3 conditions are satisfied. 1. The experiment, each trial, has 2 possible outcomes, denoted generically S for success and F for failure. 2. The trials are independent, meaning that the outcome on one trial in no way affects the outcome on the other trials. 3. The probability of success, called the success probability and denoted P, remains the same from trial to trial. Number of outcomes containing a specified number of successes. In n Bernoulli trials, the number of outcomes that contain exactly x successes equals the binomial coefficient parentheses n over x. Binomial probability formula. Let x denote the total number of successes in n Bernoulli trials with success probability p. Then the probability distribution of the random variable x is given by p of x equals n choose x times p to the x power times 1 minus p in parentheses to the n minus x power. X equals 0, 1, 2, and so on until we get to n. The random variable x is called a binomial random variable and is said to have the binomial distribution with parameters n and p. Binomial probability formula. There are other ways to write your binomial probability formula. P of x equals n combination x, p to the x, parentheses 1 minus p to the n minus x power. Or p of x equals combination of n choose x, p to the x, q to the n minus x power, where q equals 1 minus p. Example. In a certain college, 20% of the physics majors belong to ethnic minorities. If 10 students are selected at random from the physics majors, what is the probability that exactly 4 belong to an ethnic minority? Let's begin with our formula. Probability of x equals n choose x times p to the x times 1 minus p to the n minus x power. In order to use our formula, we need to know the value of P, N, and X. P is our probability. Since 20% of the physics majors belong to ethnic minorities, the 20% is our probability. We just need to change it to 0.20. N is our sample size. 10 students were selected at random, so N equals 10. And we want to find the probability that exactly 4 belong to this minority, so X equals 4. Starting with my notation, probability of 4, we now want to substitute into our formula. So we have 10 choose 4 times 0.2 to the 4th power and 1 minus 0.2 to the 10 minus 4 power. Calculating. We want to start with our combination, 10, go to the math menu, over to probability, and we want NCR. Then we type in our R, which is 4, arrow right. You can either now use your times or just the parenthesis, 0.2, exponent, 4th power, right arrow to get out of the exponent, open parenthesis. You can either type in 1 minus 0.2, or you can simply type times 0.8, exponent, and then we can type in 10 minus 4, or just 6. Enter, and we get 0.088 when we round to 3 decimal places. If you don't have the Stat Wizard, you will still start with the 10, go to the Math menu, Probability, NCR, and then type your R, times 0.2, exponent, 4, times, this time I'll use 0.8, exponent, and here if you don't use 6, make sure you put 10 minus 4 in parentheses, and we get the same answer. So the probability of exactly 4 belonging to the ethnic minority is 0.088. Using the binomial probability formula. Assumptions. There are some things that need to take place before we can use the binomial probability formula. 1. N trials are to be performed. 2. 2 outcomes, success or failure, are possible for each trial. 3. The trials are independent. 4. The success probability, P, remains the same from trial to trial. Using the binomial probability formula, Step 1, identify a success. Step 2, determine P, the success probability. Step 3, determine N, the number of trials. Step 4, the binomial probability formula for the number of successes X is probability of X equals N choose X times P to the X, parentheses 1 minus P to the N minus X. Example. In one city, 31% of the population is under 25 years of age. 3 people are selected at random from the city. Find the probability distribution of the binomial random variable X, the number among the 3 that are under 25 years of age. We need to find P, N, and X, the probability that the population is under 25 years of age, 0.31. Our sample size was 3, which means our X can be 0 successes, 1 success, 2 success, or 3 successes. We want to create a binomial probability distribution, which means we're going to list our discrete random variable and then list its probability. For this problem, X will be 0, 1, 2, 3. Those are all of our possible successes. To find the probability for each value of X, instead of using the formula 4 times, we're going to use the calculator. In our calculator, we want to go to Stat, Edit, and then I'm going to clear out L2. an L1. Then I will type in 0, 1, 2, and 3 for my discrete random variable. Then I'm going to quit, and I want to find the binomial distribution. So we want to press second VARS for your distribution menu, and then we're going to go down until we find BINOM PDF. Enter. If you have the stat wizard, you want your number of trials to be 3, which is your N. You want your p-value to equal the probability of success, which is 0.31. Our x value we're going to leave blank because we want all of them. Enter. If you don't have the stat wizard, then you'll type in 3, 0.31, close parentheses. Enter again, and we'll get a row of numbers. It would be really helpful if these numbers were in a table format, like what we need for our example. So I want to store this, STO with the arrow, in L2, second, 2, enter. Now if I go to Stat, Edit, I have the list that I need. The probability 0 successes is 0.3285, 1 success, 0.4428, 2 successes, 0.1989, 3 successes, 0.0298. I can arrow over to see the number if I need to round it to more decimal places. The other option that I have to get my binomial probabilities in L2 is to highlight L2, second, VARS for the distribution menu, go down till I see binomial PDF. On some calculators it's at 0, others it's at A. Press enter. This one's without the wizard, so I'm going to type 3, comma, because that's my N, then 0.31, that's my probability, enter, and I have the same list. Using 4 decimal places, I can create my binomial distribution. When x is 0, the probability 0.3285. When x is 1, the probability is 0.4428. When x is 2, the probability is 0.1989. When x is 3, the probability is 0.0298. Binomial distribution. Here we have 3 different histograms for 3 different binomial distributions with a parameter n equals 6. My first distribution has a probability of 0.25, and it is right skewed. The second distribution has a probability of 0.5, it's symmetric, and our last distribution has a probability of 0.75, and it is left skewed. So when looking at a probability going from 0 to 1, the closer it is to 0, the more right skewed it is. The closer it is to 0.5, the more symmetric it is, and the closer it is to 1, the more left skewed it is. Mean and standard deviation of a binomial random variable. The mean and standard deviation of a binomial random variable with parameters n and p are, respectively, mean equals n times p, and the standard deviation equals the square root of n times p times 1 minus p. In this example, we are using the data regarding 3 people selected at random from a city, where we know that p is 0.31 and n is 3. Find the mean and standard deviation of the binomial random variable x. So using our formulas and substitution, mu equals n times p, so that equals 3 times 0.31, which gives us a mean of 0.93. For the standard deviation, it equals the square root of 3 times 0.31 times 1 minus 0.31. And that gives us 0.801. Sampling in the binomial distribution. Suppose that a simple random sample of size n is taken from a finite population in which the proportion of members that have a specified attribute is p. Then the number of members sampled that have the specified attribute has exactly a binomial distribution with parameters n and p if the sampling is done with replacement, and has approximately a binomial distribution with parameters n and p if the sampling is done without replacement and the sample size does not exceed 5% of the population size. So these are the parameters that we use to decide if we can use a binomial distribution with our sample. Example: the probability is 0.35 that a traffic fatality involves an intoxicated or alcohol-impaired driver or non-occupant. In 7 traffic fatalities, find the probability distribution of the binomial random variable y. As always, we need to find n and p. P is our probability of success, 0.35, and n is our sample size, 7. We want to create our binomial probability distribution. Since n is 7, we're going to start at 0 and go to 7 for our discrete random variable. Now we want to find the probability for each of those values. So we're going to go to our calculator. We want to go to our stat menu and edit to put in our list. For L1, we want to start with 0, 1, 2, 3, 4, 5, 6, and finally 7. Then move over to L2, arrow up, go to our distribution menu, second, VARS, down to binomial, PDF, enter. Our number of trials will be 7. Then you can type comma or type in for P 0.35. Enter. Enter again. And we have our answer. The first thing you may notice is 6.4e negative 4. This is how the TI 83 and 84 write scientific notation. What this number really is 6.4 times 10 to the negative 4th power. What you need to remember is that the letter E means 10 to some power, and the power is the number listed behind the E. So anytime you are writing out your probability distribution, you want to either write your number in scientific notation or you can write it in standard form. Since I have 6.4 times e to the negative 4th, that would give me 1, 2, 3 zeros. The 4th place is 6, then my 4. Either one of those numbers is acceptable for your probability distribution table. So copying our numbers, when x equals 0, the probability is 0.0490. When x is 1, the probability is 0.1848. When x is 2, the probability is 0.2985. When x is 3, the probability is 0.2679. When x is 4, the probability is 0.1442. When x is 5, the probability is 0.0466. When x is 6, the probability is 0.0084. When x is 7, the probability is 0.0006. Using our probability distribution table for our next example, In 7 traffic fatalities, find the probability that the number y, which involve an intoxicated or alcohol-impaired driver or non-occupant, is exactly 3. In our probability distribution, for exactly 3, we have a probability of 0.2679. First, I write my notation, P of 3, then I write my answer, 0.2679. Continuing with our example, we now want to find the probability that the number is at least 3. Our notation, probability at least 3. At least 3 means 3 is the smallest number, so we're looking at 3, 4, 5, 6, and 7. Adding our probabilities of 0.2679, 0.1442, 0.0466, 0.0084, and 0.0006, we get a probability of 0.4677. Continuing our example, we want to find the probability that the number y is at most 3. First, we write our notation, P at most 3. 3 will be the largest, so we're looking at x equaling 0, 1, 2, 3. So adding the probabilities of 0.0490, 0.1848, 0.2985, and 0.2679, we get a total probability of 0.8002. Continuing with our example, in 7 traffic fatalities, we're finding the probability that the number y is between 2 and 4 inclusive. Starting with our notation, P is between 2 and 4 inclusive, which means we're looking at 2, 3, and 4. 0.2985 plus 0.2679 plus 0.1442 gives us a total probability of 0.7106. Continuing with our example, the probability is 0.35 that a traffic fatality involves an intoxicated or alcohol-impaired driver or non-occupant. We're still using n equals 7. We want to find the mean and standard deviation of y. Using our formulas, for the mean, we want to find 7 times 0.35, which gives us 2.45. For our standard deviation, substituting, we get 7 times 0.35 times 1 minus 0.35, and when we take the square root of that answer, we get 1.26. To recap the section, the binomial distribution. A factorial is when you have a number followed by an exclamation point. You want to multiply from that number all the way down to 1, subtracting 1 as you go. Bernoulli trials are repeated trials of an experiment for which each trial has 2 possible outcomes, success and failure. The trials are independent, and the probability of success remains the same from trial to trial. The binomial probability formula says that if you have a Bernoulli trial, then you have n choose x times the probability of success to the x power times 1 minus the probability of success to the n minus x power. The mean and standard deviation of a binomial random variable are very easy to find. The mean is just n times p, where n is the total number of trials and p is the probability of success. And the standard deviation, sigma, equals the square root of n times p times 1 minus p.